Unity's Universal Render Pipeline is a very different beast from the original Unity renderer. I've been asked a few times on the channel to do a video on it, and I found a great video. If you go up to the top right there in the video, you see the little card there. I found a great video there that covers the subject, and it contains a link to further resources. And you really should check out that article as well. And the link, along with the link to the source code for this, is in the description box below. So the video and the article, they cover the subject, and they contain links to further resources as well. In this example, I was asked to create a lookup table using the URP. What is a LUT? It's called. A lookup table is basically, it takes a value from 0 to 1, and then it maps it to a color in a small image file. The files are, X pixels across by 1 pixel depth. And so you take that 0 to 1 and you map it to 0 to x minus 1 pixels, and that gives you your color for it. It's typically used if you want to, monochromatically. Let's say you've got like a series of grays or whatever. Well, actually, grays you can do quite easily, and we'll show you that in just a sec. But we're going to be using a Game Boy palette in this one. So it goes from dark green to light green, and it gives a kind of 1980s feel to the game. So the value is determined using the NTSC luminosity calculation. So it takes the red value, multiplies it by 0.21. It takes the green value, multiplies that by 0.7. It takes the blue value, multiplies that by 0.07, adds them all together, and then that gives you a score from 0 to 1. We then use that number to map to the Game Boy palette using the LUT image. And the way it was recommended in the article was use shader graph. So I used shader graph for the first time in this project. I'm similar to other shader editors that I've used in the past. In fact, I've actually written one a long time ago when I was at another company. So in this example here, I'm going to take the input texture, the image that's going to be rendered to the screen, and the LUT texture as inputs, and then I use a variety of nodes to strip out the RGB values to calculate the luminosity, and that's what's going on in this video here. Once that's done, I then use the UV sampler of the LUT image to find the appropriate color by sampling the image at X, where X is actually the luminosity, and 0.5 in the Y. And I could probably have just left this at 0, but what are you going to do? I created a material for the shader. This bit's required for later, but this next bit wasn't necessary, but I wanted to make a test. I wanted to basically test it and make sure that the shader was working. So I applied the material to a cube, and I set the main texture to be a swirly pattern. The pattern looked just fine, so I knew the shader was working. The BlitRenderPass script's execute method takes input from the pipeline, applies the material, the one we created in the previous step, to the image, and then passes that altered image into the next stage in the pipeline. The feature, called in this case MyBlit feature, contains the setup code for the new render feature. Check out the add render passes method, for example. The beauty of this thing is these two scripts, now that you have them, you can apply it to any custom shader that you want. So all you need to do is create a custom shader, create a material for it, and then use that material to plug that into the render pass. And we're just going to do that just now. Now finally select the renderer that we're using. You can do that through the asset panel. There's a few that are in there. By default, Unity chose the URP high fidelity renderer, but you can always check by going through the project settings to find the right one. Now that we have that selected, add the MyBlit feature, render feature, open up the settings for it, and apply the material, and boom! The effect is immediately shown in the scene and the game view. And that's it. Thank you so much for watching, and I will catch you in the next video. Bye bye.